While in another video, I have a set of practice problems dealing with converting quadratic equations from standard form to factored form. In this particular video, let's go ahead and practice converting quadratic equations that are in vertex form to standard form. And just to remind you, let me show you what vertex form looks like. Typically, we're going to have y is equal to a times the quantity of x minus h squared plus k. And so while each practice problem here starts in vertex form, we're going to convert each of them into standard form, which again takes the form of y is equal to ax squared plus bx plus c. And if you'd like to download this free PDF and do these problems with me, feel free to do so. There's a link to that in the description box below. Let's get started. For number one, we have y is equal to the quantity of x plus 2 squared plus 4. So technically there's a 1 in front of the parentheses, but we don't have to deal with that. The first thing what we're going to do here is, I'm just going to write this out to be super clear, but this x plus 2 squared really means the quantity of x plus 2 times the quantity of x plus 2. And then we're going to add 4 on the outside. So remember that you have two of these binomials. Next, we're going to go ahead and distribute or FOIL this whole thing out. So x times x times 2, 2 times x, and then 2 times 2, right? So if we do that, I'm going to write this first one out a couple more steps than I will for the others. But we're going to get x squared plus 2x plus another 2x plus 4 plus another 4, okay? At this point, you're going to notice that we have some like terms here. So we have this 2x and 2x, they can be combined. And we also have these constant terms at the end here, this positive 4 and positive 4 that can be combined. So at the end here, we're going to get x squared plus 4x plus 8. All right, so this would be our standard form for this quadratic equation, and a is equal to 1, b is equal to 4, and c is equal to 8. For number two, we have this y is equal to the quantity of x minus 3 squared minus 2. So what I'm going to do first is I'm going to expand this binomial that is squared and just write the quantity of x minus 3 times the quantity of x minus 3. And then we're going to take away 2 afterwards. Then again, we're going to multiply x times x, then multiply x times negative 3 times x, and a negative 3 times negative 3. If we do so, then we're going to get x squared in the beginning. We're going to have a minus 3x from the outers and a minus 3x from the inners. And then negative 3 times negative 3 is positive 9, and then we're going to take away 2 at the end. Then we can go ahead and combine this negative 3x and negative 3x, and combine this positive 9 and negative 2. And so if we do that, we're going to get x squared minus 6x, and then plus 7. So that's going to be our equation written in standard form. A is equal to 1, b is equal to negative 6, and c is equal to positive 7. For number three, we have y is equal to the quantity of x plus 1 squared plus 5. So from here, we're going to go ahead and expand this. So we're going to have the quantity of x plus 1 multiplied by x plus 1, and then we're going to add 5 onto that afterwards, okay? We're going to go ahead and multiply this x by x, then multiply x by 1, this 1 by x, and this 1 by 1. If we go ahead and write that out, x times x is going to be x squared, x times 1 is going to be a positive 1x, x times 1 again is going to be another positive x, and then 1 times 1 is going to be 1, and then we have a plus 5 at the end here. Okay, we're going to combine these positive 1x's, and we'll combine these constants of 1 and 5. They're like terms with each other. And then at the end here, we're going to have x squared, then x plus x is going to be 2x, and then 1 plus 5 is going to equal 6. So that's going to be our standard form. A is equal to 1, b is equal to 2, and c is equal to 6. For number 4, we have y is equal to the quantity of x minus 5 squared plus 7. So let's go ahead and write this out. So this means that we have x minus 5 written twice, so x minus 5 and another x minus 5. And then we're going to add 7 here at the end. We'll go ahead and distribute this x to the x, then this x to the negative 5 times x, and negative 5 times negative 5. If we go ahead and do that, x times x is going to be x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x again, and negative 5 times negative 5 is positive 25. Then we have the 7 hanging out over here as well. Negative 5x can be combined with each other, and 25 plus 7 can be combined as well. So we're going to get x squared, negative 5x combined to make negative 10x, and then 25 plus 7 is going to be positive 32. So that's our standard form equation, where a is 1, b is negative 10, and c is 32. Let's check out number 5. For number 5, we have y is equal to the quantity of x minus 4 squared minus 5. So let's go ahead and rewrite this out. This is going to be x minus 4 times the quantity of x minus 4. So we have 2 of those, and then we're going to take away 5 afterwards. Let's go ahead and multiply this x by this x, then x by negative 4 by x, and negative 4 by negative 4. Multiplying this out, x times x is going to be x squared. X times negative 4 is negative 4x. Negative 4 times x is another negative 4x. Negative 4 times negative 4 is positive 16, and we have a minus 5. Checking out our like terms here, negative 4x, it's going to double up there. And then we have a positive 16 and a negative 5. Those are going to combine as well. So we're going to get x squared, then negative 4 make negative 8, so minus 8x. And then 16 minus 5 is going to be positive 11. So this is going to be our equation in standard form where a is 1, b is negative 8, and c is positive 11. For number 6, we have y is equal to the quantity of x plus 6 squared plus 7. So let's go ahead and write this out and expand this. So we're going to have the quantity of x plus 6 times the quantity of x plus 6, and then we're going to add 7 afterwards. We're going to go ahead and multiply x times x, and then x times this positive 6, then 6 times x, and 6 times 6. If we go ahead and do so, x times x is going to be x squared, x times 6 is going to be 6x, 6 times x is another 6x, 6 times 6 is 36, and we have this plus 7. We can combine the 6x and 6x no problem, as well as this 36 and 7. And so if we do that, we're going to have x squared, we're going to have a plus 12x, and then 36 plus 7 is 43. So here is our quadratic equation written in standard form where a is 1, b is 12, and c is 43. For number 7, we have y is equal to the quantity of x minus 3 squared plus 8. So let's go ahead and expand the binomial here and write the quantity of x minus 3 times the quantity of x minus 3. Hopefully you're getting the hang of this a little bit better now. Okay, so we'll distribute and multiply x times x, then x times negative 3 times x, and negative 3 times negative 3. If we go ahead and do so, x times x is x squared, x times negative 3, negative 3x. Hopefully you get the picture. We should get another negative 3x, and then plus 9, and then a plus 8. Okay, if we do that, we got some like terms here, as usual. These double up, and then this 9 and 8 will combine as well. So we're going to have x squared out in front, negative 3 makes negative 6, 9 plus 8 makes 17. So we have our quadratic equation like this: a is 1, b is negative 6, and c is 17. For number 8 here, let's go ahead and see if we can write this equation of y is equal to x plus 7 squared minus 4 in standard form. So let's go ahead and expand this. This is going to be x plus 7 multiplied by x plus 7. And then we're going to take away 4 afterwards. Let's see, this x is going to multiply by this x, then it's going to multiply by 7. Then the 7 here gets to go times x, then times 7. So multiplying this out, we get x squared plus 7x plus another 7x plus 49 minus 4. 7x and 7x are going to double up as usual, and then this 49 minus 4 is what we're going to combine at the end. So we're going to get x squared plus 14x plus 45. That's our equation in standard form where a is 1, b is 14, and c is positive 45. All right, for number 9, now since this is a new type of problem, I will write out all the work specifically for number 9, but moving on, I will skip a step when foiling or distributing just to save a little bit of time. Hopefully you're starting to notice the pattern for those perfect square trinomials though. Okay, so for number 9, let's try to be extra detailed, but hopefully you're going to get used to foiling pretty easily. So let's go ahead and expand this x plus 3. This is the part I'm kind of talking about. When you multiply x plus 3 times x plus 3, that should kind of be familiar, okay? And so if we go ahead and distribute, I'll go ahead and draw these arrows again. But remember, you always end up squaring the first thing in the binomial and the last thing in the binomial, and you always end up doubling the product of the two. So written out one more time here, we have 2 times, and it's going to be x squared, and then later on I'm not going to write plus 3x, I'll just go straight to writing plus 6x. But hopefully you've noticed that in every practice problem so far, or if you didn't notice, now you know that they'll always double up. Okay, so again, these 3x's are going to double up here. And so before we can combine anything, let's just go ahead and write 2 times the quantity of x squared plus 6x plus 9. and then we're going to add 1 outside here. So in the future, I'm just going to skip, instead of writing plus 3x, we'll just go straight to writing 6x. Okay. At this point, we do have to do a new step, which is distributing this 2. It's not that we didn't really have to do it before, it's just that before there was a 1, so if you distribute a 1, nothing happens. Technically you could say you're distributing a 1 before, but we just didn't write it. So 2 times x squared, 2x squared, 2 times 6x is plus 12x, and 2 times 9 is going to be 18. So we're going to have to write this as our trinomial and then add the 1 here at the end. And then we can add together 18 and 1 finally at the end to get 2x squared plus 12x plus 19. So this would be our final equation in standard form, where a is 2, b is 12, and c is 19. For number 10, we have y is equal to 4 times the quantity of x minus 2 squared minus 5. So again, if you need to write out an extra step, feel free to do so, but I'm going to skip a step here. So we're going to write 4 times the quantity, and I will write out the x minus 2 squared for this one, but hopefully you'll get the hang of it as we keep going. So I will draw these arrows as well, but I'm going to go straight to writing the trinomial, combining those middle 2 terms. Okay. So if you need to pause, feel free to do so. Otherwise, let's try saving a step here if we can. All right. So again, you will get x squared by multiplying x times x, and then we will get a negative 2x and a negative 2x, but instead of writing both of those, I'll just go straight to writing minus 4x, and then negative 2 times negative 2 is positive 4, and then we're going to write minus 5. Okay, so that's what we get after combining those terms, and then we're still going to have to distribute this 4 on the outside. So 4 is going to have to multiply by all 3 of these terms. Okay, so we have to distribute that. So 4 times x squared, 4x squared. 4 times negative 4x is negative 16x, and then 4 times 4 is going to be positive 16, and then we're going to take away 5. We can then combine these constants at the end here. So we're going to go ahead and say that's 4x squared minus 16x, and then 16 minus 5 is 11. All right, just like that. A is 4, B is negative 16, and C is 11. For number 11, we have y is equal to negative 3 times the quantity of x plus 2 squared plus 4. Let's go ahead and write this out. Let's take this negative 3, and then we're going to go ahead and I'll write out the binomials one more time here of x plus 2 and x plus 2. Okay, and then we're going to add 4 on the outside here. So we'll go ahead and multiply x times x, then x times 2, then we have another x times 2, and then we have 2 times 2. All right, so we have negative 3 out in front, then x times x is x squared, then we get a 2x and another 2x to make 4x, then 2 times 2 is going to be 4, and then we have a plus 4 at the end. Distributing negative 3 to all 3 of these terms, negative 3 times x squared is going to be negative 3x squared. Negative 3 times 4x is going to be negative 12x. Negative 3 times 4 is going to be negative 12, and then we have a plus 4 at the end. Finally, we'll combine these constants at the end. So finally, we're going to have negative 3x squared minus 12x minus 8. All right, and so our final quadratic equation has a value of negative 3, b is equal to negative 12, and c is equal to negative 8. For number 12, we have y is equal to negative 5 times the quantity of x minus 1 squared minus 3. So for these ones, I'm going to go ahead going forward to try to save a step if possible. So instead of writing out x minus 1 times x minus 1, let's see if we can make the trinomial right away, because they have the same pattern every time. So we will have to square the x, right? That always happens. And then we're going to have x minus 1, x minus 1. So we're going to have a negative 1x and a negative 1x. They will combine to make negative 2x. And a negative 1 times negative 1 will get us a positive 1. So if we want to go ahead and FOIL, that's what we should end up with, okay? And so if you want to pause and go ahead and write that out, then feel free to do so, okay? I'm going to go to distribute this negative 5 next to all 3 of these terms. And if we do that, negative 5 times x squared is going to be negative 5x squared. Negative 5 times negative 2x is going to be positive 10x. Negative 5 times positive 1 is going to be negative 5. And then we have a negative 3 out here. These constants can be combined, and so finally we're going to get negative 5x squared plus 10x minus 8. This is in standard form. Hopefully that didn't go a little too fast, but if you can FOIL out those perfect square trinomials without writing it out, that'll save you a little bit of time as well. But if you're making mistakes, then totally write it out, up to you. Okay, so a is equal to negative 5, b is 10, and c is negative 8. Let's check out 13. All right, for 13, we have our first fractional a value. So we have y is equal to 1/2 times a quantity of x minus 2 squared plus 4. So if we write this out, we're going to have 1/2 here. And let's go ahead and see if we can write this trinomial without writing out all the work for it. So we always square the first term, so x times x is x squared. We will always square the -2 and get plus 4 at the end, but what goes in the middle? -2 times x is -2x. We'll have two of those, so -2x and -2x make -4x, and then plus 4. So if you want to pause and write it out, go ahead, but that's the trinomial you should end up with. And then we have a plus 4 at the end. Then we'll go ahead and distribute this 1/2 to all three of these terms. And if we do so, we're going to get 1/2 x squared minus 2x plus 2, and then we have a plus 4 on the outside. We can finally combine these constants at the end here. So at the very end, we're going to have 1/2 x squared minus 2x plus 6. So this is standard form. A is 1/2, B is -2, and C is +6. For number 14, looks like we have another similar problem with a fractional a value, except it's negative, so it's an upside down parabola. So let's go ahead and just keep this -1/3. We can't use it quite yet. Let's see if we can FOIL out this x plus 6 squared without writing it out. So again, we should have x times x to get x squared. We should have a 6x and 6x and get 12x. Again, you can just multiply those two together inside and then double it. And then 6 times 6 is going to be 36. So that would be our trinomial. And if you need to think about that, go ahead and do so. And then we'll have a -8 along the outside. Okay. Then we can go ahead and distribute this -1/3 to all three of these. If we do so, then we're going to get -1/3 x squared. A third of 12 is going to be 4, so it's going to be -4x. And then a third of 36 is going to be 12, so it's going to be -12. And then we have a -8 on the outside here. Finally, we have these constants that can be combined. So we're going to write -1/3 x squared minus 4x and then -20. So here's standard form where a is -1/3, b is -4, and c is -20. For number 15, we have y is equal to 2/3 times the quantity of x minus 3 squared plus 6. Let's go ahead and give this one a try. Let's keep the 2/3 out here, leave it alone. And let's see if we can FOIL this x minus 3 squared binomial. So x times x, we will get an x squared to start. Then we'll have a -3x and another -3x, so that makes -6x. Just take some practice to get used to seeing that. And a -3 times -3, this should always be a positive value and a perfect square. So it's going to be +9 and then +6 at the end. Okay, then we'll go ahead and distribute this 2/3 to everything inside here. If we go ahead and do so, then 2/3 times x squared is just going to be 2/3 x squared. Then 2/3 of -6, well, 1/3 of 6 is 2, so 2/3 must be 4, so -4x. And then 2/3 of 9, well, 1/3 of 9 is just 3, so 2/3 must be 6. Let's put a +6 here and another +6 on the outside. These constants can be combined at the very end, and so we'll have 2/3 x squared minus 4x plus 12. All right, so that'll be our quadratic equation in standard form where a is 2/3, b is -4, and c is +12. Finally, for number 16, we have y is equal to -3/2 times the quantity of x plus 8 squared minus 7. So let's give this a try. We have this -3/2 out in front. Let's go ahead and see if we can FOIL this out. X times x is going to be x squared, and then 8 times x is 8x, but we got to double that, so we're going to have 16x because we'll get two of the same. Then 8 times 8 is 64. Okay, and so that's going to be our trinomial, and we're going to have a -7 on the outside. Then we'll go ahead and distribute this -3/2 to all the terms inside here, just like this. And just take your time with this, but -3/2 times x squared is going to be -3/2 x squared. Let's see, what's 3/2 of 16? Well, 1/2 of 16 is 8, so 3/8 gets you 24. So that's going to be -24x. And then what's half of 64? Well, half of 64 is 32. So 2/2 would be 64, 3/2 would be 96. So that's going to be a -96. And then we have this -7 on the outside. Finally, at the end, we'll combine this -96 and -7, those constants. So we have -3/2 x squared minus 24x minus 103. So that's our equation written in standard form, where a is -3/2, b is -24, and c is -103. So there you have 16 different practice problems on turning quadratic equations written in vertex form to written in standard form instead. If you found this video helpful, please consider giving it a thumbs up and letting me know in the comment section down below. And again, if you'd like free downloads of the blank worksheet or the answer key worksheet that we just finished writing together here, feel free to find the links in the description box and you can download those or print those or do whatever you need to help you learn. As always, keep up the great work, and I'll see you in the next one.